Thank you. Our next presentation will be on the Plans Preparation Manual by Ben Jarrell, our Quality Assurance Engineer, and Matt Jacobs, our Design Manual Specialist. At this time, I'm going to turn it over to Ben.
Thank you, Jackie. Matt and I will begin today with an overview of the Plans Preparation Manual update process. Then I'll discuss shoulders and super elevated sections, retaining wall access, and right-of-way. As many of you know, the Plans Preparation Manual, also known as the PPM, consists of 2 volumes. Volume 1 contains design criteria and procedures for the FDOT, and Volume 2 covers plans preparation and assembly of contract plans. Both volumes are in English units, and you can find PDF files with bookmarks for each chapter of Volume 1 and Volume 2 at the website shown on this slide. And we also provide we not only provide the most recently updated PPM, but we also have archived manuals that date back to the 1960s. Updates to the Plans Preparation Manual are constantly in the works. Our team of district roadway design engineers represent each of the 7 districts and the Turnpike. They meet twice a year for a day and a half, and every month for a few hours to work on proposed revisions to the manual. These proposed revisions are received throughout the year from various sources. We often receive draft language from other departments such as structures, standards, utilities, and planning. The draft language is reviewed at the district roadway design engineering meetings, and sometimes the draft language is changed several times before it's ready to be reviewed by the district design engineers and the Federal Highway Administration. The district design engineers and FHWA review the draft PPM and provide comments on the proposed language for adoption by the state engineers. Once the revisions are adopted, then the updated PPM can be prepared and posted on the PPM website. For those of you who are registered, can receive notification of the latest PPM updates. I'll hand it over to Matt for now so he can tell you more about the process and our website.
All right, thanks, Ben. All right, we have a plethora of great resources available, but they are only useful if you know where to find them. A great place to start is the Roadway Design website. On our website, you'll find some excellent resources such as the Implementation Design Bulletins. An Implementation Design Bulletin is published every year to summarize the updates made to the PPM and to establish how these changes will be implemented. The Implementation Design Bulletin is available on our website through this link. Also on this site, you can find the complete PPM in PDF format. These 2 complete volumes and individual chapters are available for your convenience. All forms included in the PPM are updated accordingly and are accessible through this link. Training programs and courses offered by various offices in the Office of Design are made accessible to you through the link at the bottom of this page. To ensure we receive notification of all updates or revisions, you can register in our website by entering your personal and business information in areas of your interest in the contact mailer. A roadway design bulletin is published when a roadway issue is identified that must be addressed prior to the next release or update of the PPM, design standards, etc. Registered customers will receive contact mailer notifications. The most recent roadway design bulletins are posted on our website listed here. Previous roadway design bulletins are accessible through this link. Here's a snapshot of our most recently archived design bulletins. These are archived for your reference. And as always, please let us know if you have any questions as to where certain information is, and we'll be happy to assist you. Thanks.
Thanks, Matt. So now I'll go over the 3 major changes to the PPM today. Those topics are shoulders and super elevated sections, retaining wall access, and right-of-way. Super elevated roadways can be more difficult to construct than tangent roadways in normal crown. They're not normally this difficult to construct. Now, this is a picture of the Daytona Speedway being paved about 3 years ago. And this section of the Daytona Speedway is steeper than any super elevated section in our roads. Of course, we don't design roads for cars that can exceed 200 miles per hour. And this turn is banked at 31 degrees compared to a maximum super elevation of 10% for our rural roads. So there are limitations of paving equipment and tools that we have to consider when designing super elevated roads. The screed of an asphalt paving machine can be 8 or 10 feet wide, and then extensions 4 or 5 feet wide can be added in either side. These extensions are designed to pivot so they can resurface an adjacent section of pavement with slopes different from the main section of the paving machine. This allows paving crews to pave a travel lane and a shoulder at the same time. And that works fine in tangent sections and in super elevated sections not super elevated greater than 5%. The problem occurs in sections super elevated at 6% or greater where the paved shoulder is not flat. And here's an asphalt paving machine in operation. It's paving the outside travel lane and the outside shoulder with a 5-foot extension. This change is intended to improve constructability of new roads with paved shoulders less than or equal to 5 feet in width on roads super elevated 6% or greater. Shoulders rounded in the center with narrow paved shoulders were difficult to measure with the 4-foot level to see if they met criteria. They were also difficult to construct economically. The double asterisks were added as shown in this figure, and along with a note at the bottom of the figure. Now this note states that for shoulders with paved widths 5 feet or less, see special shoulder super elevation detail, which is the new figure we have added. And this figure is 2.3.1b, and this figure was added to provide criteria for several different shoulder widths. Now let's look at the first detail. For full shoulder widths, 8 feet, 10 feet, or 12 feet, with paved shoulder widths less than or equal to half of the full shoulder width, the shoulder will slope upward to the midpoint of the shoulder, then slope downward for the remaining shoulder width. This is an example of a curve on a 4-lane divided roadway where this detail could apply. The second detail was added for 8-foot shoulders with 5 foot of paved shoulder. In this case, the shoulder will slope upward for the paved widths, then slope downward for the remaining shoulder width. In this case, it'll slope upward for 5 feet and then downward for 3. And this is an example of a curve on a 2-lane undivided roadway where this detail could apply. The third detail was added for 6-foot shoulders with 5 feet or less of paved shoulder. In this case, the shoulder would slope upward for the entire 6 foot of shoulder. There have been a number of, going on to the next topic for retaining wall access, there have been a number of retaining walls on our roads that have been constructed with little if any maintenance access. Retaining walls require some maintenance, such as crack sealing, spall repair, and graffiti removal. Maintaining these walls requires having access for personnel or vehicles in order to perform this necessary repairs. And here's an example of a retaining wall with no clear access, making it difficult to do maintenance. You may notice the pink and yellow graffiti on the wall. Now this is how it looks from the top of the wall. Makes it pretty difficult to get down there. A sentence was added in section 2.4 to provide a 10-foot flat area from the face of an adjacent retaining wall, allowing clear access for the maintenance vehicles and personnel. Now this is an example of a retaining wall with clear maintenance access, and it looks like the wall is being maintained. The 10-foot flat area is not intended for gravity walls. Gravity walls have a maximum height of 5 feet and can be accessed more easily than tall retaining walls. Our next topic, right-of-way. Now this change is intended to give designers clear direction in regards to property owners' intentions and disposition. There has been some level of inconsistency in the use of license agreements and temporary construction easements. So let's first go over the use of temporary construction easements versus license agreements. If the property is intended for completion of the project, then the owner should be compensated and a TCE obtained. If the property is not intended for the project, but is more for the benefit of or desire of the property owner, then no compensation is required and a license agreement should be obtained. The PPM was revised in Volume 1, Section 12.2.2. The design engineer can neither assume the property owner's intention or disposition with respect to his or her property, nor assume that a cure plan contained in the department's appraisal or in the owner's appraisal will actually be built by the property owner. Now, if you're wondering what a cure plan is, a cure plan is a proposal submitted by the appraiser to restore value to the remainder. It's just a proposal. FDOT does not actually do the work in the plan, and the owner gets the money to effectuate the cure. In summary, shouldered and super elevated sections, we have a new figure 2.3.1b, and this is for paved shoulders less than or equal to 5 feet with super elevated curves 6% or greater. And then retaining wall access, we updated section 2.4 roadside slopes to allow for require a 10-foot flat area adjacent to the retaining wall. Remember, this is not for gravity walls, and this allows for maintenance on the retaining walls. And then for right-of-way, section 12.2.2, we added language here, and its gist of it is, don't assume property owner's intentions or disposition, and don't assume a cure plan will be built by the property owner. Thank you, and I hope this has been helpful.
Hello, I'm Andre Pavlov of the State Structure Design Office, and today I'm going to talk about the 2014 PPM changes for bridge vertical clearance. The reason for the change in our policy was that the district design engineers were signing variations for existing bridges with vertical clearances between 16 feet and 16 feet 6 inches. They were saying that the district structure design engineers were saying that in no cases were they ever not approving them. So as we started making the changes, we went back to see exactly reviewed some of the criteria from AASHTO and the PPM. And from AASHTO, the policy is pretty clear in section 7.2, 7.3, and 8.2 that the clearance requirement is 16 feet over the entire roadway width. Also stated is that additional clearances should be allowed for future resurfacing. So what we did is we went back into the PPM, and we really didn't change any of the criteria for new bridges, but we explicitly stated that the table 2.10.1 was for new bridges. This table, some of the notes were also changed, but the clearance requirements on this table remain the same. And we did the same thing for the tables for sign and signal structures, and we just consolidated them into one table and put the word new into the table. So these clearances did not change, but they are, the clarification here was that they were for new sign and signal structures. Section 2.10 of the PPM was added to. Currently, or last year, there was only one sentence in that section. Now we have 4 paragraphs. And I want to go over each one of these kind of briefly here. In the first paragraph, the first sentence stayed the same. The second sentence was brought over from section 25.4.13 of the PPM, so it was really a better location for it here in Chapter 2 as opposed to Chapter 25, and the wording stayed the same. And then the third sentence here in this section deals with how to measure vertical clearance, and it just clarified how to measure it because there were some questions that were raised about that. The next 3 paragraphs deal with the actual change in policy. The second paragraph states that if you have vertical clearances, if you have existing bridge vertical clearances less than 16 feet, that they shall be maintained and increased. And also, if you're reducing the vertical clearance, an existing bridge vertical clearance to values between 16 feet 0 inches and 2 inches, that you need to put a note in the plan stating that that is a minimum, and that the requirer should do a survey to confirm that the vertical clearance will be 16 feet or greater in the final condition. The second paragraph deals with signs. Also, it states that dynamic message signs shall be maintained or increased. You're really not allowed to decrease existing dynamic message sign clearances. And the third paragraph was added by at the request of the DSDEs for existing traffic signals. Chapter 25 also had a section on vertical clearance, and we went in there and made some changes as well. I talked about the one sentence that was removed from this chapter and added to Chapter 2. And the bridge low member clearance information or requirement there has changed as well. And that's in the unlikely event that you have some sway members that hang over a roadway. And if you have a case like that, you need to contact the district structures design engineer. So what this means is that, and this has been asked several times, is that if you have an existing vertical clearance between 16 feet and 16 inches, can construction reduce that clearance down to 16 feet? And the answer is yes. And also for signs and signal structures, well, mostly sign structures, if you have vertical clearances of 17 feet 6 inches, you can reduce those down to 17 feet for an existing structure as well. And does this require design variation? No. That was the purpose of all these changes. We do have a requirement for DMS structures that states that the clearance on them should be 19 feet 6 inches for new construction. The reason for that is that it was a precautionary measure taken back in the 90s to reduce vibrations due to truck gusts on these large DMS boxes. So if you have an existing DMS structure and it's performing well at 17 feet 6 inches or 17 feet 0 inches, there's really no need to do anything. The 19-foot 6-inch requirement for new construction is really just a precautionary measure. AASHTO treats DMS structures just like any other overhead sign structure. And that concludes my presentation, and now I'll take any comments or questions.